A very good morning to you, and you're very welcome to today's Signpost webinar. I hope you're keeping safe and well wherever you're joining us from today. My name is Mark Gibson, and I'm the manager of the Teagasc Connected programme. The series is brought to you by Teagasc in collaboration with Dairy Sustainability Ireland, the National Rural Network, and Food Drink Ireland SkillNet. So today we continue our discussions about hedgerows, but from a slightly different perspective, and I'm delighted to be joined by Stuart Green, who is Senior Researcher in the Agribusiness and Spatial Analysis Unit in Teagasc. Stuart, you're very welcome to our Signpost webinar.
Thanks, Mark.
And Pat Murphy, you're joining us from Wexford this morning. Pat, you're the head of the Knowledge Transfer Programme on the environment side of things. How are you today?
Great, not a bother. Nice morning.
Good. Yeah, it's not too bad here in Galway. It's dry at least. So, Stuart, you're working in the whole area of remote sensing and viewing Ireland from a very different perspective. Could you tell us a little bit about the work that you're doing in the Spatial Analysis Unit?
Yeah, we use satellites and drones and aircraft to sort of view Ireland from above, so we can map agricultural production, the agri-environment, forestry. We're doing a lot of work around measuring grassland biomass, grass growth remotely from satellite, and on soil properties, things like soil drainage, soil types, and so on. But we've also done a lot of work over the years on hedgerows, mapping and monitoring hedgerows. So that's what I hope to talk about today.
Great. And Stuart, you also have a map of the month that you publish from Teagasc. Can you tell us a bit about that? Because I know viewers might be interested in following that series. It's a fascinating series of maps that you've created for Ireland.
Yeah, so every month we dig up one of the maps that we produce. So as well as using the satellites, we also do a lot of geography using GIS, Geographical Information Systems, to make maps, because maps are really good at communicating ideas and knowledge. So once a month we pick one we've produced that month usually, or sometimes an older one from the archive, and we put it on the Teagasc website, and we have a discussion around it and share it around. And it does get a lot of interest. People like maps.
Yeah. Where's the best place for people to find those?
If you can Google Teagasc Map of the Month, and it'll take you straight there to the page on the Teagasc website. But it's also put through Teagasc social media. So if you're following the Teagasc Twitter account or the Teagasc Facebook page, it pops up there once a month.
Okay, so Stuart, if I could ask you to share your screen with us, and you're going to be talking to us about hedgerows in general, but also about the carbon sequestration potential, or that potential measurement of the carbon sequestration side of things. Just to remind people, if you'd like to ask Stuart a question, please do use the Q&A tab at the bottom of the screen, and we will have a Q&A session after Stuart's presentation. So Stuart, I'll hand over to you.
Great, thanks, Mike. Okay, so I'm Stuart Green, and what we're going to look at is how over the years hedgerows have been mapped and monitored in Ireland. We're going to go from the gold standard of putting boots on the ground and standing next to the hedgerow and taking measurements, and we're going to then look at more up-to-date techniques that give us overall maps for the country for the hedgerows. So, why do we map hedgerows? Well, if we don't know what we have, it's hard to value it or put a value to it. Because we know from Hedgerow Week this week, I'm sure everyone watching understands that hedgerows are sort of the foundation of farm biodiversity. But they also play a massive role in controlling runoff and surface hydrology on the farm that's somewhat underappreciated. But also, more importantly, in the last, say, decade, their potential as being stores for carbon on the farm and carbon sequestration in the context of the emissions from Irish farming has grown more importantly. So that's been one of our focus in mapping these hedgerows. Now, the gold standard, as I say, is field mapping. So this is going on the ground, and Ireland's got a good history of doing this. It's created through the Heritage Council a formal appraisal system that's sort of 70 pages long, led by Neil Fuchs, who's done a lot of the county surveys. And Neil's probably one of the most important people in terms of hedgerow appraisals and understanding of mapping of hedgerows. And he's part of the Hedge Association. And what the system does is it gives you a way of measuring not just the physical properties of the hedgerow, the length, the density, the number of plants and so on, but it looks at the botanics of the hedgerow, the plants, the animals that live there, looks at the history, the age of the hedgerows. So it's really, really detailed understanding of what's in a hedge. And you can't replace that with technology. You know, you need people on the ground to look at the hedgerows. But it does take time. So there's maybe a dozen counties have done a survey. This is where you take every 10 square kilometers, you take 1 square kilometer in the top left-hand corner, and you survey all the hedgerows in that square kilometer. So you can imagine physically going to those places and doing those surveys. It takes a long time, and the amount of detail that's collected means it can be quite an expensive procedure, because you're collecting data on the cover, the structure, the habitats and the plants. So if we can come up with a way of speeding up at least part of that process, and maybe instead of having a survey, having a complete wall-to-wall map of at least where the hedgerows are, then those maps that are produced go a long way to support the detailed work that's done in the surveys. And the easiest way of doing it, to get some idea, is, and everyone can do this, the software is freely available online. You can do it on Google Earth if you want to. Many farmers will be familiar with the idea of mapping their farms digitally from their cap payments. And you know, it's simple and quick to do, and you won't get much information. You'll get the length of the hedgerows, and if you click around the boundaries of the hedgerows, the borders, you'll get the area of the hedgerow. But it's a useful exercise to do, and we've done it on the Teagasc farms, and it's been done on many other farms. And you know, you'll get some information there on the length of the hedgerow and the area of hedgerows on your farm or the area you're interested in. So this can be done quickly by anyone with a little bit of practice. There is another source of information on hedgerows from a European survey called Lucas, and the Lucas survey is carried out in every European country every 3 years. And what happens is that the surveyors, they go to literally a spot on the ground every 2 kilometers, and they take a photograph of what's on the ground, literally at their feet, and then at the 4 cardinal points around. But whilst they're there, they also look across a transect, a line, and they record features on that transect. And one of the things they record are hedgerows, and whether it's a hedgerow, an unmanaged hedgerow, or a stone wall. And there you can see the sort of data we can get. We can see the managed hedgerows caught in the survey here on the east part of the country, unmanaged caught around here, and then stone walls up in the limestone regions. But we tried 15 years ago now to produce a map of all the hedgerows and all the scrub and all the individual trees in the country. Because whilst the forestry is captured in the inventory from the Forest Survey, the extent of the hedgerows and scrub was unknown at that point. So this was very much a first see. We used early technology in looking at the colour and texture of hedgerows on the available aerial photography from the Ordnance Survey. And we trained the computer to recognize these things. So we can see here's the original photograph, the color photograph, and here is the hedgerows and scrub picked out automatically in yellow. It was very provisional. It didn't work very well in every part of the country due to the nature of the imagery that was captured. It was an early stage appraisal, but it gave us some figures. It gave us an idea that approximately 6% of the country was covered by hedgerows, scrub, tree lines, individual trees, which was it was a much bigger estimate than previously been made. Hedgerows up to then had been thought of in terms of length rather than area, but if you want to calculate things around carbon and volume, you need the area. But it has been used. We've used it. It was part of our assessment of high nature value farmlands, which we produced a couple of years ago. where we took a number of indicators, and obviously hedgerow area as a percentage of farmland is a strong indicator of the nature value of the farmland. And so we were able to produce this map here of high nature value farmland in Ireland. And also we looked at one of the issues that initially was a problem in training the computer to recognize these objects was shadow, but also shadow is one of the reasons why hedgerows are trimmed and cut. Farmers want to reduce hedgerow. And we showed that indeed throughout the course of the year, at the ends of the year, sort of spring and winter, hedgerows, say up in the northwest, they can cast a shadow over 10–15% of the field for much of the day. So this is an important consideration when we think about how we're going to manage hedgerows and why they may be cut or altered. But we understood that if we want to know more about the hedgerow, we have to recognize that they're 3D objects. You know, they stand up in the ground. So a number of years ago, ourselves and Kevin Black in Furs, we did a project for the EPA where we use laser scanning. So we had laser scanning is called LiDAR, and this is a laser that is mounted on an aircraft, and it flies over an area, and the laser continually shoots down very high frequency pulses of laser, and the length of time it takes for the laser to reflect back to the aircraft tells you something about the distance from the aircraft to the object that it's been reflected from, and therefore using some complicated computing, you can calculate a 3D model of the landscape. So this is the sort of thing that we can get. Literally a 3D model. This is high density, so this is 10 points every meter, every square meter. So we get an awful lot of detail. And actually within the laser pulse and within the structures like hedgerows, what we find is that the laser doesn't bounce off the top of the hedgerow, because the laser penetrates in the hedgerow. So we get a lot of information about the structure of the hedgerow and the density and what the hedgerow is built on. So we can do things like here is a virtual cross section of a hedgerow from one of these laser scans. And we can see the bank and the ditch. And here we can see a denser hedgerow. And we looked at methods for converting that information into volume information. So we could say how much, what volume did the hedgerow occupy? And then we used existing models to estimate, well, if we know the volume of the hedgerow, we know the density of the hedgerow, we can then estimate how much carbon is in the hedgerow and how much carbon the hedgerow sequesters as it grows annually. Now, this was an approximation because there was no existing models of how much carbon is in a hedgerow. So essentially we had to pretend the hedgerows were tiny trees, which is not exactly right. We'll talk at the end of this morning on a new project from Teagasc that's going to improve these models. But when we did this modeling, we estimated that hedgerows would sequester, so if a typical mature hedgerow would sequester something on the region of 1.9 tons of carbon per hectare per year, but with a wide range going from 0.6 to 3.2 as the upper limit. And this does fit with other work done in England and in France, where they found hedgerow sequester on the rates between 1 and 2 tons per hectare. So this is significant. And of course, if we were to look at it in terms of our estimate of the area, we'd be looking at maybe 0.7 million tons of carbon. But it is only an estimate. And just to remind you that this range of, say, 1.9 tons is at the low end of the sort of emission ranges that Teagasc sustainability reports put on Irish farming. So it's a low end sequestration rate per hectare compared to some of the emissions from some Irish farming systems. One of the issues with LiDAR is it's expensive. It was more expensive then. It's less expensive now. The more the technology matures, the more data that's acquired, it gets less and less expensive. But so we did another project called Briar, where we tried to use another form of remote sensing. This is a radar satellite. So overhead, going all the time, are satellites, especially in the Sentinel Copernicus program from the European Space Agency. But one of the issues in Ireland with satellites is, of course, most of the satellites can't see through cloud, and it's cloudy a lot. But there's a type of satellite called a radar satellite, which sends out pulses of microwaves in the same way that the LiDAR sends out pulses of light. And these pulses of microwaves, they penetrate through cloud and they reflect back off the ground. So we tried using a satellite called Terracer X, which has got very high resolution, down to a few meters, to see if we could relate the strength of the signal that bounces back from the hedgerow with the density and therefore the carbon of the hedgerow. Before we did that, we had to get some what we call ground truth. We had to get real measurements of hedgerow. And in this part of the project, we created a new method of surveying hedgerow for structure in terms of height, width, volume, counting trees, counting gaps and so on. And this was done by Kevin Black in Furs. And this is using a drone. And just a normal drone, nothing fancy about it, and using what's known as photogrammetry, where when you fly the drone, the photographs are continually taken, so they overlap each other, and this overlap allows you to exploit the stereo effect so that we can build 3D models of the hedgerow. Now, they're not as good as the laser survey because these ones do actually just go over the top of the object it's looking at. So we can't penetrate into the laser, but it does allow us very quickly to survey an entire length of hedgerow and get good information on the height, the width, and counting crowns and so on in the hedgerows. So this is now a new standard, and indeed it's going to be used going forward in a new project I'll talk about in a few moments. So there's one of the Terracer X images. In fact, it's a mosaic of a number of images. And if anyone recognizes it, there's Moore Park, Teagasc Research Centre. And you can see the hedges very well. But in fact, what our studies showed is that Irish hedges are so dense and so packed with biomass that in fact they saturate the signal return from the satellite. So you can't distinguish ranges of density because they're all too dense for the radar to penetrate. They essentially kind of look like stone walls almost to the radar. But what we did show is that this technology is really very good at spotting hedgerow removal. So we get very different returns when we take a hedgerow away compared to when it was present. So it does have a role to play in monitoring the national estate of hedgerows. We looked at lots of different methods to try and extract information, and we did present some papers on using the radar signal to get at least the structure, say the height and the width. But ultimately, we went back to old techniques to look at some issues around changes over time. So we looked at samples of hedgerows from 1995, comparing them to 2015 in a number of counties. And we had an estimate of, in those 20 years, you can see an example of internal hedges being removed as part of a farm restructuring. And here we can see hedgerows being removed as towns expand. And we found that between those 20 years, roughly 3% of the hedgerows in 1995 had been removed by the time we got to 2015. Now, this doesn't take into account all the new hedgerow that was planted under gloss, because that was sort of a lot of that's post 2015. And those new hedges would probably be too small to detect for a good number of years before they got mature. Anecdotally, as we surveyed the hedgerows, we found that there was periods where the hedgerow removal was being dominated by farm restructuring, but then obviously in the Celtic Tiger period, a lot of the hedgerows were being removed in road building, house building and town expansions. And we were able to estimate the amount of hedgerows in the country. We looked at unshared boundaries on farms. So these were farm boundaries around roads, rivers, and so on. We looked at shared boundaries. These are boundaries farm. These are hedgerows between neighbours, and then internal farm boundaries. We broke it up in this way because again, shared boundaries are the least likely hedgerows to be removed. Good fences make good neighbours and so on. And again, roadside hedgerows and riverside hedgerows, they're very unlikely to be removed. So if any hedgerows are going to be restructured, it's going to be the internal ones. And we estimated overall 690,000 kilometres of hedgerow, which is an enormous amount. Roughly broken up within half as an unshared boundary, 15% as a shared boundary, and the remainder as internal farm boundaries. So that was where we got. So we had methods for estimating carbon, which we've used on our sample sites and in other places. For instance, if you were listening last week, we've heard about the surveys that were done in Douth. We have methods for measuring the length of hedgerows from the imagery, and so we can estimate the total length of hedgerows in the country. Now, when we did that, what we looked at was this idea of boundary biomass, because traditionally hedgerows have quite a tight sort of botanical definition, whereas we wanted to get all the biomass that's on the the field margins, on the boundaries, because that's significant in terms of carbon. So this is all the hedgerows, but it's all the relic hedgerows, it's all the overgrown banks, it's trees, tree lines, it's hedgerows alongside forest parcels, which typically wouldn't be counted as hedgerows. So we get everything that's sort of a woody biomass on the boundary of a field. So in order to improve our estimates of carbon, our colleagues in Johnstown Castle, along with FIRS, have an EPA-funded project called Farm Carbon, run by Lillian O'Sullivan, and they are building special models of how much carbon exactly is stored in traditional Irish hedgerows. So they'll be measuring the carbon. They'll be cutting down some hedgerows to weigh them and burn them and so on, and they'll be looking at the amount of carbon that's collected in the litter. So we'll get a really, really good specific model for Irish hedgerows. So therefore, when we come to do a new survey of the volume and the height and the structure of Irish hedgerows, we can use those figures and the data from this study to give really good, accurate estimates of the sequestration potential of hedgerows, but just as importantly, the carbon that's stored in the hedgerow, but also stored underground in the bank of the hedgerow. And then in order to turn that into a national estimate of all the carbon, excitingly, there's a new product that Teagasc has been involved in the development of from the Ordnance Survey and the EPA, and this is finally a new national land cover map. And this is going to be available probably mid next year, sort of June 2021. And this is every field, everything in the Irish countryside will have a label of what it is. So it'll be improved grassland, wet grassland, waters, roads, buildings, forests, young forests, and excitingly hedgerows are included. So using the sort of techniques that we used 15 years ago, but in a new machine learning environment, and exploiting the Ordnance surveys, what they call the photogrammetric point cloud. So this is, these are sort of 3D information. The system can automatically very accurately delineate hedgerows. So we can get the area of the hedgerow. And we've got some information on the height of the hedgerow from those two, and from the models that Lillian will be producing, we'll get extremely good models of total amount of carbon stored in Irish hedgerows. There's an example of the sort of thing that the map will finally look like in terms of a seamless coverage. So, in 2021, our hedgerows are probably valued more than ever. And we're finally going to have in place from 2021, we're going to have a way of measuring and monitoring all hedgerows. So we'll have accurate maps of where the hedgerows are now. The national survey will be, the national land cover map will be updated every 3 years. And we're going to then be looking at estimates of carbon in hedgerows from Lillian's project. And we can now automatically map changes, planting of new hedgerows, removal of old hedgerows, and we can look at the management of the hedgerows. And hopefully there'll be projects in the future where we can show what's the best way to manage a hedgerow in terms of improving its carbon store. And this is, how do you allow it to grow? How do you manage it and trim it? What do you do with the cuttings? So, I can see a point in the future where we'll be managing hedgerows, not just for biomass, not just to be stock-proof fences, but to improve their carbon storage. And this can all be monitored remotely and automatically using satellites. Okay, that's me done.
That's great, Stuart. Thanks very much for that. That was, I suppose, a totally different perspective that we're used to. We're usually boots on the ground, and I suppose remote sensing has offered a lot in terms of, I suppose, hedgerow mapping, but also I know I had some involvement in the soil mapping project as well. So there was a lot of GIS involved in that project also. You talked about LiDAR, Stuart, as sounded like the holy grail in terms of mapping and getting that 3D image of the country. I mean, would it be a massive cost to scan the entire country?
It would be expensive. I mean, again, not just doing it, but licensing it. I mean, there are private companies that provide laser surveys, so you wouldn't want to kind of be taking the bread from their mouths in the sense of doing it for free. So there'd be licensing agreements and so on. But I do know that in the north of Ireland, they're about to produce a national laser survey of the whole 6 counties and make it available to NGOs, third-level colleges and researchers. So I think at some point we're going to realize that having a really good 3D model is probably really vital for the country in terms, not just for hedgerows, but really important for things like runoff and hydrology and planning and so on. So I think we're going to get there at some point, but it'll be a good while yet.
Mm-hmm. You mentioned the challenges with the Irish climate, cloud being the biggest problem with aerial mapping and satellite mapping. I mean, how far away are we from having satellites that will give the sort of resolution that we get with aerial photography that from? They do exist.
There's lots and lots of satellites. So there's lots of free information from the European Space Agency, but there are literally scores of private companies that provide very high sort of meter resolution satellite imagery. The issue generally is that the higher resolution you are, the smaller the image, so you need more of them to cover the area, and generally they don't go over as frequently because they're looking at a smaller area in terms of their orbit. So the chance of getting a cloud-free image for Ireland gets less. But now we have companies that are producing these sort of small microsatellites that are going over in a sort of like a train in orbit. And they have so many of them, we get a high repeat rate. So again, your chances of getting a cloud-free image is much higher than it was. But you'd be paying plenty of money for those high-resolution imagery. Whereas the free European Space Agency 10-meter resolution, it does the job for most agriculture.
Pastor, there's some interesting questions coming through there for Stuart.
Yeah, there's one here. Can you use any of these mapping systems to compare from one year to the next to show areas that are maybe too overly zealous managed and thus aid advisors and farmers to better management for pollinators and wildlife?
Probably year to year is not possible. For instance, the Ordnance Survey, who produce the aerial photography that's used in the land cover map, they would be doing that every 3 or 4 years. So that's a sort of repeat cycle. If you are willing to buy one of these high resolution satellite images, and anyone can, all you need is a credit card, you could easily do that. And that's what we did over 5-year cycles, looking at change. It's one of the things. Hedgerows are quite easy to recognize from an aerial photography, just manually, and it's very easy to see when they've been removed.
One here, does the predicted carbon sequestration of the hedgerow take into account the removal and burning of cuttings, or what?
No, so it wasn't done in a full life cycle assessment, again, because we just didn't have the data. I'm not sure whether Lillian's project is going to a full life cycle again, but I do know there's work on the continent in Germany and in France on what is the best way to manage the hedgerow in terms of improving its carbon sequestration. And one of those things is things like turning the cuttings into charcoal or composting them and burying them. And that improves soil quality as well as sequestering that carbon that's taken off the cuttings. I do know that the work in England is kind of showing that if you want to improve carbon sequestration, you want to make your hedgerows wider rather than taller, interestingly.
Okay, and a related one. Hi, Stuart. Is there any significant difference between species of trees in sequestering carbon for trees that are the same size and age? For instance, sequester more than ash, or?
I don't know. It's not my bailiwick. Unfortunately, I point the instruments at them, and then other people tell me what goes on in that sense.
I presume again that's where the Lillian's type work on characterizing will come in.
Yeah, and you have to treat the hedgerows differently to the trees. So in these models, what we tend to do is we sort of virtually extract sort of individual trees that are growing in hedgerows and treat them differently to the hedge below them.
Will hedgerows in outer suburban areas be captured by the new national land cover map?
They will, yes. What might be, there's a tiny difficulty, I think, in terms of hedgerows in suburban gardens. They may be captured as part of other elements in the map. There's a minimum length for these things will be to be captured. So some will, some won't.
We have a question, Stuart, in relation to the use of these type of technologies for actually maybe planning how we plant hedgerows, or indeed looking at the connectivity of hedgerows and the corridors that are created by hedgerows. Do you have any insights on that side of things, and also around riparian zones and tree lines?
Certainly we had, there's been work as sort of the Network for Nature principle, where you take these maps and you allow them to run together, the hedgerows, and therefore you can look at the impact. Do hedgerows, if they join small pockets of scrub, does that make a bigger impact than the pockets of scrub by themselves? So that work has been done and looked at, and it'll improve enormously when we get this new map in the middle of next year. In terms of runoff and repairing hedgerows, yeah, and this is where the LiDAR comes in, because if you have the 3D surface of the country, you can use models to show where runoff will be occurring and point source pollution. And therefore, if you're planning a new hedgerows are really good at intersecting that sort of runoff. So instead of, say, buffering an entire stream in your farm and blocking the whole thing off, it might be possible just to plant sections of hedgerows to stop the runoff and send it into the ground.
Sure, it's an area that is changing very quickly. The science is really moving very fast in this whole area. I mean, casting our eyes to 10 years' time, I mean, what do you see the potential that this type of technology offers us from an environmental monitoring perspective? Or, I mean, I'm sure, surely you have ideas, I'm sure, about future uses of these types of maps and remote sensing.
Yeah, I think it's, you know, some of these things are always 10 years away and may always remain 10 years away. But certainly we'll be looking at, in terms of agriculture, there'll be, you know, routine or weekly field scale maps of grass growth rates and crop growth rates. They're almost here. They're nearly ready to roll out, derived directly from satellite. I know a lot of the monitoring for things like for bogs and for Natura 2000 will increasingly rely on satellite data. I know as well, I suspect that drones will become a bigger part, both on the farm, for the farmer, in terms of surveying the farm, especially around security and biosecurity. But also I know the likes of EPA and the Parks and Wildlife are using drones to look for fly tipping and things like that. So it becomes more and more embedded in our sort of environment, I think.
Okay. I just want to remind everybody that today's presentation and webinar is brought to you as part of the overall activities that Teagasc is undertaking as part of Hedgerow Week. So if anybody wants to find out a little bit more about all of the various different elements of Hedgerow Week, you can go onto the Teagasc website and view all of the different videos and articles that have been produced each day this week. So there's a treasure trove of information there about hedgerows, all different aspects of hedgerows from all different parts of the country. So I encourage anybody with an interest in hedgerows to take a look at that. If you just go onto the Teagasc homepage and go to just click on there is a very big link on the homepage there that brings you to that information page. Sorry for interrupting, Stuart, but just in case people weren't aware of that. Pat, some lots of questions coming through there for Stuart.
Yeah, I suppose a left field one. Is there any technical solutions available for helping identify invasive species in hedgerows?
Yes, we have looked at that ourselves. You can do it. It depends on the species, depends on how they grow. So for instance, if you get the timing right, you may be looked. I know there's been examples of Himalayan balsam has been picked out through when the blossom is showing. Knotweed as well can be detected in hedgerows if it's big enough. If it's underneath the hedgerow, obviously it's not possible to see. So it certainly is possible to look at invasive species with this. Whether again the cost benefit works, it's up to the councils, I suppose, to decide.
A question there, I suppose, about Teagasc making available the maps that are being developed, and to what degree will they be available?
Well, with Teagasc, the land cover map is being produced by the Ordnance Survey, and so that will be available under what's known as the National Mapping Agreement. So I think it'll be visible on the Ordnance Survey GeoHive site, and then anyone covered by the National Mapping Agreement, local authorities, research bodies, third levels, NGOs, and so on, they'll get access to it.
Hedgerows within forestry, are they calculated as part of the forest in relation, or is there kind of a dual counting of them?
No, I just mentioned the hedgerow in relation to forestry is because when they're, in terms of the definition of a hedgerow in terms of the botanics, it's sometimes, if it's growing next to a forest, it's not considered as a hedgerow but part of the forest. So it's only a definitional thing. It's not about whether it's accounted for in carbon.
Just a question here, Stuart, in relation to the shadow effect that you talked about, and that a wide is better than a tall hedge. Have you any idea about the loss of productivity in a field if the hedge is too high? Is that's a
no, there's no formal measures, but as I said, it depends on the height of the hedge. It depends on the size of the field. But I do know, anecdotally, talking to people in the sort of the hedge laying and the hedge managing business, that one of the reasons you see very low hedges in tillage areas is because farmers are concerned about this shadow effect. But But as we get increased sort of biodiversity strips in tillage farms alongside hedgerow, I think that becomes less and less of an issue, and maybe those hedges can be allowed to grow back again.
A question here, can any of these systems aid in creating a connected or a network of corridors of hedgerows or tree lines to aid biodiversity? So I suppose it's back to the planning side of trying to develop connectivity within the habitats that we have.
Absolutely. I mean, it can't be done automatically. I mean, that's a decision of the landowners who want to do this. But I think once these maps are available and people see just where the hedgerows are and how they connect to each other and what the impact of, two hedgerows crossing, what's going on in that corner of the field and how much biomass is growing there, I think it will make people being cooperative in terms of, say, planning small forests on their farms, so they join up and connect. I know there's a project in Donegal, I think, I can't remember the name of it, where they're looking at increasing the environmental impact of farm forestry by encouraging farmers to cooperate in terms of where they're placed on the farm in connection with the wider landscape.
There's a question there in relation to the density of hedgerows, that if we do change our management, as I suppose the focus of what we're trying to do with Hedgerow Week is okay, to add to the hedgerow bank stock, but also to change the management, allow for hedgerows to go taller, to be broader. Will we be able to pick that up in this kind of analysis in terms of getting a sense, well, if we do manage this, we'll be able to spot better management and then target better management, and also then to be able to count that from a sequestration perspective?
The short answer is yes. I mean, it's you do it maybe every 3 or 5 years. It's that sort of scale where you'd see the impact that's been measurable by looking at the aerial photographs of the satellite. But actually, that's the absolute intent of something like the land cover mapping program, is to show the area increase of hedgerows as we go forward.
And there's a question there, to what extent are you seeing reduction in the amounts of hedgerows across the landscape in recent years?
Well, we've not had the data to look at it in recent years. So the last set of orthos, aerial photography we've access to is from 2015. So we don't really know what's going on. We know that the department gives license to clear hedgerows, so we have those figures. And we know how many thousands of kilometers of hedgerows are planted under gloss, but we don't know where they are yet. So when we get access to the new set of orthophotography, then we'll be able to have an estimate of what the increase is. And my gut feeling is that probably we've got a net increase in the last 5 years just because of the amount of stuff that's been planted under gloss.
Just as a short, slightly aside to hedgerows, Stuart, the whole area of water quality and water quality monitoring and monitoring the changes in water bodies. Are you aware of much work going on in that area? And because this is obviously a big issue for farming in Ireland, is pointed as one of the contributors to reduced water quality. Is there much work going on in terms of riparian zones and that type of work?
Well, there's certainly a lot of work being done on the interface of farming and water quality. There was a large project in Johnstown Castle, which looked at the effect of buffering and stopping animals accessing water for drinking and for crossing fields. So there's a lot of advice now based on that research on how you can keep animals out of the stream and away from the stream and the rivers. So that's where the thrust of the research is. There's been work done, as I say, on 3D modeling of point source pollution and critical source loads in catchments and on farms using laser scans. And so if you know that there's a spot in the field where the water is tending to run, surface water is tending to run into the field, into the stream, you can do something about it at that point rather than just crudely applying buffers to the entire farm. And that's been done under the catchments program, that research. And we showed in our own department, we showed that if you have a tightly managed sward, so you're not an improved grassland, then you can use everyday drones to get really good 3D models of your farm, and they're good enough to see where the water is running off in your farm. So there is a lot of work done on that in terms of water quality in farming.
Stuart, just looking way ahead, do you think we could ever get to a point where these information systems could actually be used to advise farmers to say, well, listen, this hedge could do with being trimmed, this hedge is okay to let it go for another while, there would be good biodiversity impacts of filling in X. I'm just saying, is that a point in the future that we might get to, that we could really use this technology to assist farmers in management?
Well, to some extent, it's being done. I mean, if you take it right down to the field scale, more and more, as you know, Pat, that farmers are interacting with authorities and with advisors through photography. They take their smartphone, take a photograph, and the advisor isn't visiting the farm; they're doing it remotely. So there's already examples of imagery being captured by the farmer on the farm, and then advisors saying, well, do this and do that. So if we wanted to, in terms of hedgerow advice and how to trim it, it's a simple job to take a photo for the farmer to take photographs of the hedgerows and get advice. If you want to get this done remotely, again, it depends on how frequently this imagery is captured. But certainly I could see every advisor, both in the private sector and in Teagasc, having the land cover map on their desktops. So when they're talking to a farmer on the phone, it pops up immediately into the farmer, so the advisor can see the whole farm in the image with the elements labeled, and therefore that brings on the discussion between the farmer and the advisor.
A question there: Are Stonewalls the poor relation of Hedges in the study?
A little bit. We have studied Stonewalls, and we always make the point that Stonewalls are as valuable in terms of, say, their biodiversity. Obviously, no role in carbon storage, but in terms of biodiversity on the farm and habitats for creatures like nesting bees and so on, they're really important. So our focus was hedgerows because of the carbon, but we don't forget Stonewalls.
A question there: have Teagasc looked at native tree planting in hedgerows as opposed to non-native? And that again may not be your area of expertise, and we might refer back to Catherine's talk last week, where she is absolutely passionate about ensuring that we use not only native species but also native provenance in terms of the production of the stock for planting. So if to answer that question, I think maybe look at Catherine's presentation during the week and go back on some of the planting material that has been put up on the website during the week to answer that. Mark?
Okay. Right. I think we're coming close to the end of our webinar this morning. Stuart, I want to thank you for giving us an excellent presentation. This area, I'd love if you could come back to us maybe again in a little while, because I mean there's so many different dimensions to this whole science of remote sensing, and obviously it offers a lot in terms of savings rather than having to be ground truthing. And I often have conversations with some of the retired colleagues who were involved in some of the earlier mapping exercises, the soil mapping projects, which were hugely resource intensive and going out in fields, and look, a certain extent of that is still is in place, but no, it's a fascinating area. So thank you very much, Stuart, and Pat, thank you for your assistance today. Next week, we'll be talking to Professor Alan Matthews, who's going to be talking to us about emerging trends in EU policy CAP, the Green Deal, Farm to Fork, and also I hope to have an opportunity to talk to Alan about Brexit also. If you'd like to receive updates on training opportunities, latest publications and invitations to events from Teagasc, I encourage you to sign up to the Teagasc Connected program for free today, and you can get a link to that at the end of this webinar. And finally, I'd like to thank our production team, in particular Andy Boland, Catherine Keena, Pat Murphy and Yvonne Maher. This is drawing a close to Hedgerow Week. But as I said, there's lots of resources for you to avail of on the Teagasc website. Just go into teagasc.ie and click on Hedgerow Week, and it'll bring you to a huge library of videos, articles and updates on hedgerow planting and management. So with that, I want to wish you well, and hope you can join us for the final in our series for 2020. And we will be recommencing the series back in January. We do apologize to those of you who were inadvertently removed from our registration process. There was an issue that occurred with Zoom during the last 2 weeks, and we are still looking into that. But hopefully you can encourage other people to sign up for the series as well. So with that, thank you for your attention, and we will talk to you next week. Bye-bye.
Bye-bye.